Hey, welcome back to another edition of the Flipped Classroom. Tonight we're going to learn about exponents. So let's go ahead and get started. Exponents, what are they? What does it mean? Well, you've seen exponents before. You've all seen exponential formation, exponential notation that looks like this. 5 to the second power. Here's the biggest thing. You're probably already thinking, oh, that's easy. It's just 5 times 2 equals 10. Well, congratulations. You would be absolutely wrong. That is not what exponents are all about. That's the most common mistake. And I'm going to tell you right now, at the beginning, do not ever make that mistake. Do not just multiply the bigger number to the smaller number. Don't do that. That is not what exponents are all about. Exponents contain two parts. They contain a base, which is the large number, the 5 in this example, and they contain an exponent, which is the small number that's raised up to the right-hand side. The way we read exponents, or exponential notation, is we say 5 to the second power. The base is the only factor you're allowed to use and multiply it over and over to itself. The exponent simply tells you how many times you should multiply the base to itself. So 5 to the second power actually means you take a 5 and you multiply it again by a 5, and you do it 2 times. Why 2? Because the exponent is 2. So you have 2 5s. So it's 5 times 5. The value is actually 25. Never make that mistake and just say, oh, that's 5 times 2 equals 10. Done. Wrong. Never is correct. Let's look at a couple examples real fast. Repeated factors. Let's look at A. A is showing us 4 times 4. Well, if we want to write that using an exponent, we can just simply put on the base, which is 4. I know that's the base because that's the factor that's being repeated. And how many times is 4 being repeated? Well, I see 1, 2. So I could raise it to the second power. 4 to the second power. The value? 16. Because 4 times 4 equals 16. Let's look at E. I have 3 times 3 times 3 times 3. Well, my base, the number that's being repeated, is 3. How many times is 3 up there? 1, 2, 3, 4. So this is illustrating 3 to the 4th power. What's the value of 3 to the 4th power? Well, let's see. 3 times 3 is 9. So this 3 times 3 is 9. And I know my basic facts. 9 times 9, 81. Okay? You can pause the video here after you've watched it the first time and go back and actually practice those problems. We will, tomorrow in class, we will add notes to our learning log all about exponents. Okay, we'll talk about the powers, we'll talk about the base, the large number, we'll talk about the exponent, the small number. But you should have a great understanding what it means, what they are, and 3 to the second power. Anything to the second power, we can say squared. We'll talk about that in a second. 3 to the third power. Anything to the third power, because we can use a fancy word, a fancy name, we can say it's cubed to the third power. Those are the only two that have fancy names. Everything else, you simply say the base, the number 3, to what power? Well, to the 4th power. This would be 7 to the 8th power. A huge number. Again, the biggest mistake, which you all will never ever do, is read this and say 8 to the second power. That's easy. 8 times 2 is 16. Again, wrong. Never ever do that, okay? This is actually 8 times itself, because there's 2 8s. 8 to the second power, 8 times 8, which equals 64. So again, never make that mistake. Next question. 2 to the third power, 2 cubed, or 3 to the second power, 3 squared. Are they the same? If we just take them, can we just flip-flop the base and the exponent? If you just flip-flop them, will you get the same value? I don't know. Let's investigate. Ask yourself what 2 to the third power looks like. And here's what you should say. You should say I have a base of 2, so I'm going to use 2's, and I'm going to have 3 of them. 2 times 2 times 2. And that equals 2 times 2 is 4. 4 times 2 equals 8. This one over here, we have a base of 3. So 3 to the squared, 3 to the second power. I'm going to use a 3, and I'm going to have it 2 times. 3 times 3, which equals 9. 8 does not equal 9. So no, we cannot just flip-flop. They are not the same values. They do not mean the same thing. So we really have to focus on what the base is and what the exponents are. 3 to the second power. 3 squared, we say. Why do we say squared? Well, here's why. You can literally make an array, as you learned in 4th and 5th grade. And here we have 9 circles, and we have 3 rows and 3 columns. So it's a 3 by 3, 3 times 3, 3 by 3 array, and it makes a perfect square. 9, the value of how many dots there are, 9 is called a perfect squared number. 8 is not a perfect square. You can use the factor pairs of 8, 1 times 8, 2 times 4, but you can never make an actual perfect square. You can make rectangles, you can always make a rectangle, but not an actual perfect square. Here's what I want you to do now that you've watched this video. I want you to solve these 9 problems. Take your time. Obviously, you're going to want to pause the video here, work it out on a sheet of notebook paper, and bring it with you to class tomorrow. Okay, you can always rewatch this. Have a great time. Have a great night. Do it. I'll see you tomorrow. Bye-bye.